am Balaji Rao. Welcome to BR Max class. In this class, we will learn about matrices. I am following NCERT textbook of class 12 Matrices chapter. The order will be same like NCERT textbook class 12. Okay. In this class, we are going to revise complete theory part related to exercise number 3.1. If you are good in all this theory part, you can do exercise number 3.1 problems very easily. This video is going to be little longer video. Have patience. Many definitions are there. Types of matrices, diagonal matrix, scalar matrix, identity matrix. All the definitions are going to come one after another. Okay. So let's begin the class. This chapter name is matrices. Matrices. First definition. What is matrix? What is matrix? Definition of matrix. Rectangular arrangement of numbers is called a matrix. I will talk about these functions in third example. First one. Rectangular arrangement of numbers is called a matrix. Simple words. Okay. What is matrix? Can you say along with me? What is matrix? Rectangular arrangement of numbers is called a matrix. For example, you see this arrangement. What arrangement is this? You join all these lines. You join all these numbers. You can identify the shape of a rectangle. So this arrangement is rectangular arrangement of numbers. That's why it is an example of matrix. And this arrangement, whatever the numbers are there, they will be written in between the brackets like this. Okay, what we are learning? We are learning about matrix. What is matrix? Rectangular arrangement of numbers is called a matrix. Okay, now you see this arrangement. Is it a rectangular arrangement? Actually, it looks like a square arrangement. But we know that every square is a rectangle. Every square is a rectangle. Even though this is square arrangement, it is a rectangular arrangement also. That's why this is also example for a matrix. Okay. Now you see this rectangular arrangement of numbers or functions I specified in the functions. Functions means it may be trigonometric functions, whatever it is. However, I am saying these are the numbers. Actually, they are the constant functions. One is one function which is known as constant function. Okay. Here, this is rectangular arrangement or not? Yes, of course, it looks like a square arrangement, but every square is a rectangle. So this is the example for matrix. You observe this example, what type of arrangement it is. You can see here, this number, a number is missing here. This is not a rectangular arrangement. See, you observe, you join these numbers, the shape will come like this. This is not a rectangular arrangement. See here, it is not a matrix because it is not a rectangular arrangement. Okay. So what you learn in this class? What you learn now? You learn about matrix. What is matrix? Rectangular arrangement of numbers is called a matrix. Take a pen, paper and write the definition of matrix. Okay. And now we are going to discuss about 5 important points related to matrix. Okay. 5 important points related to matrix. What are those 5 important points? Okay. First point. What is the first point? Numbers in a matrix. You look here. Numbers in a matrix are called elements. Numbers in a matrix are called elements. For example, you see here A, B, C, 1, 2, 3 like that. These numbers are there. Here A is some number, B is some number like that. Okay. These numbers are known as elements. Okay. So what is the first point? What is the first point we learned? Numbers in a matrix are called elements. Very good. Now, second point. Horizontal line of elements is called a row. Horizontal line of elements is called a row. You look here. This is horizontal line of elements. This is horizontal line of elements. This is first row. This is second row. Like first row, second row. Okay. So you learn 2 things. What are elements in a matrix? Numbers in a matrix are known as elements. Horizontal line of elements is called a row. We use this row column very frequently in this matrix chapter. Okay. Horizontal line of elements is called a row. Vertical line of elements is called a column. You see here, this is first column. Look here, A1. This is first column. This is second column, third column, like that. Okay. So in this matrix, you observe here, in this matrix, how many rows are there? How many columns are there? 2 rows are there. How many columns are there? 3 columns are there. Okay. So you learned 3 points. Numbers in a matrix are called elements. Horizontal line of elements is called row. Vertical line of elements is called column. And one more thing, in general, matrices are denoted by English capital alphabets. English capital alphabets means if I say A is a matrix, then we write that matrix like this, capital A, capital B, like that we will write. Okay. So, fourth point is over. And matrices are denoted like this. You observe, so these two actually brackets difference is there. Like a closed bracket, it is like a open bracket. Whatever the method you want, you can follow. It can be denoted like this or it can be denoted like this also. So what we learned till now? We learned about matrix. What is matrix? Yes, I'm asking you, what is matrix? Rectangular arrangement of numbers is called a matrix. And we learn about elements. Yes, without seeing that, you tell what are elements? Numbers in a matrix are called elements. Sebash. And what is a row? Yes, answer me. What is row? Horizontal line of elements is called a row. What is column? Vertical line of elements is called a column. And matrices are denoted by English capital alphabets. Okay. And matrices are denoted like this or like this. I hope you understand till now what I did. It is important, take pen, paper and start writing these things, so that by the time this video is over, the revision is also will be over to you. Okay, right. Now we learn about order of a matrix. Which one is called order of a matrix? Look here, order of a matrix. If a matrix is having m rows and n columns, then we say order of the matrix is m by n. If a matrix is having m rows and n columns, then we say order of the matrix is m by n, which is denoted like this. For example, you take this matrix. With the example, you can understand this very clearly. In this, how many rows are there? This is the row, first row. This is second row. How many rows are there? 2 rows are there. How many columns are there? 3 columns are there. So, what is order of this matrix? 2 by 3. If a matrix is having m rows and n columns, then we say order of the matrix is m by n, which is denoted like this. How you read this? Some people will read it as 2 cross 3, but actual thing is it is 2 by 3. Okay. Now you observe this. What is order of this matrix? Observe here. What is order of this matrix? Order of this matrix is 3 rows, 3 columns. Right? 3 rows, 3 columns are there. In this, first row, second row, third row. First column, second column, third column. 3 rows, 3 columns are there. So order of this matrix is 3 by 3. I hope you are understanding what I am saying. Right? So you learn about order of a matrix. What is order of a matrix? If a matrix is having m rows and n columns, then we say that the order of the matrix is m by n. You observe, you take this example. In this matrix, 2 rows are there, 3 columns are there. So order of this matrix is 2 by 3. Okay. Related to order of a matrix, one important point is there. If a matrix is of order 2 by 3, number of elements in that matrix is 2 into 3. 2 into 3 is what? 6. You can observe in this matrix how many elements are there? 6 elements are there. You observe order of this matrix is 3 by 3. And how many elements present in this matrix? That is 3 into 3. 9 elements. 3 into 3, 9 elements. I hope you understand what I am saying. So, if a matrix is of order m by n, then number of elements in that matrix is mn. Okay. The same point you can observe here. If a matrix is of order m by n, then number of elements in that matrix is mn. Is that clear what I am saying? So till now what we learned? We learned about matrix. We learned 4 important points. And we learned about order of a matrix. Related to order of a matrix also we learned 1 point. What is that point? If a matrix is of order m by n, then number of elements in that matrix is mn. Okay? Now we'll move to next definition. This is important one. Representation of a matrix. Representation of a matrix. This is little difficult to understand, but while doing JEE problems or competitive level things, this type of notation they'll ask in the questions. So you need to understand what notation it is. You observe these first 2 lines. The remaining all is explanation of these first 2 lines. First we will see what are those first 2 lines. A is a matrix Aij of order m by n. You see here what they are saying? This is a matrix. They are saying this is a matrix where Aij, they are saying about Aij. What they are saying about Aij? Aij is element of a matrix which is present in ith row and jth column. Aij is an element of a matrix which is present in ith row and jth column. They are asking. Okay, right. So I am trying to explain this. Listen this carefully. I am trying to explain this notation, what it is exactly. You observe this, they are saying it is a matrix of order m by n. They are saying it is a matrix of order m by n. That means how many rows are there in this matrix? In this matrix, m rows are there. We do not know what is the value of m. Total m rows are there. In this matrix, how many columns are there? Total n columns are there in this matrix. Okay, so I am representing what is this matrix. I am expanding this. See here, this is the place present in first row and first column. This is the place present in first row and first column. So what element it is? It is the element present in first row and first column. Here they are saying Aij, so this element will be A11. Suppose if they given here Bij, then I will write B11 here. I hope you are understanding. What place it is? It is the place of first row, second column. Try to understand. That's why A12. What place it is? First row, third column. That's why it is A13. We will continue like this. And last element is what? This is the first row. No doubt in that. So this is the first row. A1. Which column it is? What is the last column of this matrix? They are saying this matrix contains m rows and n columns. N columns. That's why last element is A1n. Is that clear to you or not? That's good. Now, this is which row, which column? Second row, first column. That's why this is A21. This is which row, which column? This is second row, second column. That's why this is A22. Yes, this one, second row, third column. And it comes to last element. This is second row, this is nth column. We can continue this further. Okay, what is the last row? I am writing the last row. Last row, total how many rows are there? M rows are there. So this is AM1. That means this is mth row and first column. We know it is first column. What place it is? This is the mth row, second column, mth row, third column. What element this is? This is the last element, mth row, nth column. I hope you understand what I am saying. Okay. In this, they not specified what is m, what is n. For example, in place of m by n, they given 2 by 3. That means the order of this matrix is 2 by 3. Then how the matrix looks? Bij of order 2 by 3. This matrix contains 2 rows and 3 columns. Look here, how many rows are there? 2 rows are there and 3 columns are there, right? Here Bij is there, no? That's why I written B11. This is the place of first row, first column. B12, first row, second column. First row, third column. I hope you are understanding, right? This is which row? Second row, first column. Second row, second column. Second row, third column. I hope you are understanding what I am saying. So, from now onwards, wherever you see this one, Aij of order m by n is a matrix, then if we expand this matrix, it looks like this. If they given Bij of order 2 by 3, then the matrix looks like this. While doing problems, you will get more grip on this representation of a matrix. Okay, so that is all about representation of a matrix. What we learned till now? Yes, matrix. What is matrix? Answer to my question. What is matrix? Yes, what is matrix? Answer to my question. What is matrix? Rectangular arrangement of numbers is called a matrix. What are the 4 points you learned in that? Numbers in a matrix are called elements. Don't feel bored that I am revising all these points. It's learning. And take pen, paper and start writing all those things. Numbers in a matrix are called elements. What is the second point? Horizontal line of elements is called a row. Vertical line of elements is called a column. Okay. What is the next point we learn? Matrices are denoted by English capital alphabets. Okay. And we learn how matrices is denoted by 2 types of brackets are there. That is what we learn about matrices. Next we learn order of a matrix. If a matrix is having m rows and n columns, then we say order of that matrix is m by n. Suppose a matrix is having 2 rows and 3 columns, we say that order of that matrix is 2 by 3. I hope you are understanding, right? In order of matrix also one important point is there. If a matrix is of order 2 by 3, how many elements present in that matrix? 2 into 3, 6 elements will present. The same point I given. If a matrix is of order m by n, number of elements in that matrix is mn. Okay. Next we learn about representation of a matrix. What you need to understand about representation of a matrix? If something you saw like this, Bij of order 2 by 3, then the matrix looks like this. Okay, that's great. Now we learn about types of matrices. Initially some easy definitions are there, later main definitions will come. Okay, types of matrices. Okay, types of matrices. You see the first matrix, it is very easy. Row matrix. What is row matrix? Look here, a matrix which is having only one row is called a row matrix. A matrix which is having only one row is called a row matrix, right? See, you observe here, what is order of this matrix? Order of this matrix is one row, 4 columns are there. So what is the order of this matrix? Order of this matrix is 1 by 4. What is order of this matrix? 1 row, 2 columns is there. Order of this matrix is 1 by 2. What you understand? A matrix which is having only one row is called a row matrix. I hope you understand. What is row matrix? A matrix which is having only one row is called a row matrix. Simple definition only. Next definition, column matrix. Look here, column matrix. A matrix which is having only one column is called column matrix. A matrix which is having only one column is called a column matrix. Simple thing. You see here how many rows are there? First row, second row, third row. 3 rows are there. How many columns are there? 1 column is there. Order of this matrix is what? 3 by 1. You observe this matrix. How many rows are there? 1, 2, 3, 4. 4 rows are there. How many columns are there? 1 column is there. What is order of this matrix? Order of this matrix is 4 by 1. Yes. So in types of matrices, 2 definitions you learn. First one is what? Row matrix. What is row matrix? Yes, I am asking you. What is row matrix? A matrix which is having only one row is called row matrix. What is column matrix? A matrix which is having only one column is called column matrix. Simple. Now we are going to learn another 2 easy definitions. They are rectangular matrix and square matrix. What is rectangular matrix? See here, what is rectangular matrix? A matrix in which number of rows is not equal to number of columns. This is important. A matrix in which number of rows is not equal to number of columns. You observe this matrix. Number of rows 2, number of columns 3. Are they equal? No. So that matrix is known as rectangular matrix. Simple definition. Number of rows not equal to number of columns. Then we say that matrix is a rectangular matrix. So we learn about rectangular matrix. Next what? About square matrix. Really say what is square matrix. You look here, a matrix in which number of rows is equal to number of columns. Rectangular matrix means number of rows not equal to number of columns. Square matrix means number of rows equal to number of columns. Is called a square matrix. You observe here, how many rows, how many columns are there? 2 rows, 2 columns. Number of rows is same as number of columns. Is it a square matrix? Of course. Number of rows is same as number of columns. That's why this is the example for square matrix. Okay. Regarding square matrix, we use this point while doing the problems. If A is a square matrix of order n, they'll say that A is a square matrix of order n. Order n means what? It means that it is a square matrix of order n by n. Okay. So you learn total 4 definitions. What are those 4 definitions? First one is what? Yes, what is the first one? Row matrix. A matrix which is having only one row is called a row matrix. Next, column matrix. What is column matrix? A matrix which is having only one column is called a column matrix. Next, we learn about rectangular matrix. What is rectangular matrix? A matrix in which number of rows not equal to number of columns. What is square matrix? A matrix in which number of rows equal to number of columns. That's it. And regarding the square matrix, we learn one point. If A is a square matrix of order n, what it means? It means that it is a square matrix of order n by n. I hope you are understanding. Good. Now, we will move to next definition, which is important one. Upper triangular matrix. We are going to learn 3 definitions which are interlinked. upper triangular matrix, next one is lower triangular matrix, next one is triangular matrix. What is upper triangular matrix? Before going to know about upper triangular matrix, you know about diagonal of a matrix. What is called diagonal of a matrix? A square matrix, try to understand, a square matrix in which the line joining from first element of a first row to the last element of a last row is called diagonal of a square matrix. You observe in this, you observe these elements. This is first element of a first row, this is second element of a second row, this is third element of a third row. This is known as diagonal of this matrix. Okay, so diagonal of a matrix exists only for square matrices. Okay, now we learn about upper triangular matrix. What is upper triangular matrix? A square matrix in which all the elements below the diagonal are 0. This is the diagonal of this matrix. A square matrix in which all the elements below the diagonal are 0. You see this, below the diagonal are 0. So this matrix is known as upper triangular matrix. Why they are saying upper triangular matrix? You can see these numbers forms a triangle. This is above, these numbers, you join all these lines, it forms a triangle. So that's why this is called upper triangular matrix. What is upper triangular matrix? What is upper triangular matrix? A matrix, a square matrix. It is important, don't say a matrix. A square matrix in which all the elements below the diagonal are 0 is known as upper triangular matrix. So similarly, you can guess what is lower triangular matrix. What is lower triangular matrix? A square matrix in which all the elements above the diagonal are 0. A square matrix in which all the elements above the diagonal. You see, this is the diagonal. You see this. This is the diagonal of this matrix. You can observe all the elements above the diagonal are 0. So this is known as what? Lower triangular matrix. You same, one more example. You can see this is the diagonal. All the elements above the diagonal are 0. So this is known as lower triangular matrix. You join all these elements, what you will get? This is a lower triangular or not? Yes, that's it. I hope you are understanding, right? So what we learned? We learned about upper triangular matrix, lower triangular matrix. What is upper triangular matrix? All the elements below the diagonal are 0. What about lower triangular matrix? All the elements above the diagonal are 0. And we know about diagonal of a matrix. Diagonal of a matrix exists only in square matrices. What is diagonal of a matrix? In a square matrix, the line joining from first element of a first row to the last element of a last row is called diagonal of that matrix. I hope you are understanding, right? Good. Now, what definition is over? Upper triangular is over, lower triangular is over. Next, triangular matrix. What is triangular matrix? You see, a matrix which is either upper triangular or lower triangular is called a triangular matrix. A matrix which is either upper triangular or lower triangular is called a triangular matrix. For example, you see, this is what matrix it is. It is a lower triangular matrix. It is a triangular matrix. It is a triangular matrix? Of course. What is triangular matrix? A matrix which is either upper triangular or lower triangular is called triangular matrix. So you see this example, what matrix it is? This is upper triangular matrix. Can we call this as a triangular matrix? Yes, this is a triangular matrix. Moreover, this is upper triangular matrix. I hope you are understanding. What is triangular matrix? A matrix which is either upper triangular or lower triangular is called a triangular matrix. Okay, right. So you learn about upper triangular, lower triangular and triangular matrix. That's good. Now, most important definitions, right? Very, very important definitions. Diagonal of a matrix. Actually, for this 3 versions are there. I am writing the easiest version. 3 types of definitions are there. I will discuss those things also, but one easy version we are discussing here. A square matrix in which all non-diagonal elements are 0. This is important. A square matrix. It is a square matrix in which all non-diagonal elements are 0 is called a diagonal matrix. First thing, it is a square matrix in which all non-diagonal elements are 0. Non-diagonal elements. You can see here, what are the diagonal elements? You see, what are these? Please tell what are these? These are the diagonal elements. This is the diagonal of this matrix. Non-diagonal elements you observe. These are non-diagonal elements now. All non-diagonal elements are 0 now. A square matrix in which all non-diagonal elements are 0 is called a diagonal matrix. Is it a diagonal matrix or not? Of course it is a diagonal matrix. Right? Why? Because all non-diagonal elements are 0. You observe this is a square matrix. First point, it is a square matrix or not? Yes. Non-diagonal elements. What are the diagonal elements for this? See, these are the diagonal elements. Non-diagonal elements. Non-diagonal elements 0 or not? Yes. It is a. So this is a diagonal matrix. Now you observe this is a square matrix or not? Yes. It is a square matrix. It is a square matrix. Good. Now non-diagonal elements 0 or not? First you observe that. You may confuse here. 0 is there. That's why this is a diagonal matrix or not. First point, it is a square matrix or not? Yes, it is a square matrix. All non-diagonal elements, all non-diagonal elements are 0. See, non-diagonal elements are 0. In the definition, they specified only about non-diagonal elements. They are not specified about diagonal elements. They are saying all non-diagonal elements are 0. You see, these are all non-diagonal elements. All these are 0 now. This matrix satisfying this condition or not? Yes, it is satisfying. So what we can say? It is a what matrix? Simple matrix or it's a diagonal matrix? It is a diagonal matrix. Whatever the 3 examples I written here, they are the examples of a diagonal matrix. Simple words. What is the diagonal matrix? A square matrix in which all non-diagonal elements are 0. That's it. Simple version. Okay. Second version. What is the second version? You observe this first example. Is it is upper triangular matrix? Is it is upper triangular matrix? What is upper triangular matrix? A matrix in which all the elements below the diagonal are 0. See here, all the elements below the diagonal are 0. And you can observe this matrix. This is lower triangular matrix also, because all the elements above the diagonal are also 0. That means, what is diagonal matrix? A matrix which is both upper triangular and, I am using and, a matrix which is both upper triangular and lower triangular matrix is called a diagonal matrix. That is the second version. Third version also we can say a square matrix. Aij notation. Aij is a matrix such that Aij is not equal to 0. Sorry, Aij equal to 0 whenever I not equal to j. I will write here to avoid the confusion. Equal to 0 whenever I not equal to j. Ij represents ith row and jth column. This is the third version. I don't want to make it complicated. Simple version is a square matrix in which all non-diagonal elements are 0 is called a diagonal matrix. This is one of the important definition. And about representation, I will write here. This matrix is written like this: diagonal 1, 5, 9. What it means? It tells that all diagonal elements are 1, 5, 9. Remaining all elements are 0. Okay. Right. So we learned about diagonal matrix. Can you say what is diagonal matrix? Yes. Answer please. Involve. Yes. Answer. What is diagonal matrix? A square matrix in which all non-diagonal elements are 0 is called a diagonal matrix. That's good. Next we'll move to scalar matrix. Diagonal matrix. First of all, it is a diagonal matrix. A diagonal matrix in which all diagonal elements are same, or you can write equal. Try to understand. This is important. You should start like this. A diagonal matrix in which all diagonal elements are equal. You see, is it is a diagonal matrix or not? Is it is a diagonal matrix or not? All non-diagonal elements 0? Yes, all non-diagonal elements are 0. So this is the diagonal matrix. And a diagonal matrix in which all diagonal elements, you see, what are the diagonal elements? 2, 2, 2 is there. So this is the example for scalar matrix. You see, is it is a diagonal matrix? All non-diagonal elements are 0. Yes, it is a diagonal matrix. What about diagonal elements? All diagonal elements are same. Yes. So this is the example for square matrix. I hope you are understanding, right? Good. So two definitions, important definitions you learn. What are those two important definitions? One is diagonal matrix, other is scalar matrix. Okay. Now next important, identity matrix. A diagonal matrix. This is also important. It is a diagonal matrix. First of all, it is a diagonal matrix. You should specify this, otherwise the definition is going to be wrong. A diagonal matrix in which all principal diagonal elements are equal to 1. Not same, are equal to 1. You see, is it a diagonal matrix? Yes, all non-diagonal elements are 0. So first of all, it is a diagonal matrix. All diagonal elements are equal to 1. Yes, all diagonal elements are equal to 1. So what this matrix is? This is the identity matrix. And identity matrix is denoted by I, capital I. Okay. And you see this example. This example, is it diagonal matrix? Yes, it is a diagonal matrix. What about diagonal elements? All diagonal elements are equal to 1. Yes, that's why this is an identity matrix. So 3 important definitions we learn: diagonal matrix, scalar matrix, identity matrix. Very easy definitions, but we use these things very frequently. Okay. Next, regarding identity matrix, few points. In general, identity matrix is denoted by I. That's we discussed. IN represents a identity matrix of order n by n. Suppose you see this one. This is the example of I3. That means it is an identity matrix of order 3 by 3 now. This is the example for I2. I2 means it is identity matrix of order 2 by 2. Okay. Next, see last one, zero matrix. Simple definition: a matrix in which all the elements are 0 is called a zero matrix. Here a matrix, not compulsory it is a square matrix. A matrix in which all the elements are 0 is called a zero matrix. For example, I can give one example like this: 0, 0, 0. This is an example for zero matrix. Right? Zero matrix is denoted by 0. No, it's not 0. What we learned in the beginning, matrices are denoted by English capital alphabets. Zero matrix is denoted by O. This is O. Alright? So with this, theory part related to exercise number 3.1 is completed. In next class, I'll do all the problems in exercise number 3.1. I hope you understand this class. Making all these videos taking time, and please drop a like. It gives more energy to do many videos like this. And what you felt about this video, please let me know. For any improvements, I'll try to improve. If you are not yet subscribed to my channel, subscribe now. Thanks for watching this video. Have a great day. Bye bye. And don't forget, you please take pen, paper and write all the definitions of your own, such that the theory part for first exercise will be completed. Once you are good in theory part, then you will feel that the exercise problems are going to be very easy. Thank you.